industry. Lead, whoops, I'm sorry, we lost that here. How did that happen, John?
I don't know.
Okay. Lead, encourage, and expand international cooperation, extend human space economic activity into deep space, and preserve and expand United States leadership. The second project that came to mind that I wanted to share is the idea that the geostationary orbit can do some fantastic things for us. If Derek Weber is with us, he presented some slides in the class, and some of our students thought they were very interesting. And the Space Emergency Response Vehicle is an idea to position some assets in geostationary orbit that can shorten the period in case you needed emergency support for the Artemis mission and the Gateway mission too. There was a project called Servo, which is also part of this idea of having a rescue capability. And you see here what a Servo can do in terms of long-term scalability and cross-functionality. A third project was called Citadel, and the idea of logistics development between the Earth and the Moon. We saw that as more important, far more important than putting a station orbiting the Moon. The idea that we need to have a credible, reliable, and evolve a permanent logistic infrastructure became important. Sean McLean came to class and told us how important it is to have rescue and emergency services in the area between the Earth and the Moon that is developing very fast in the next 20 or 30 years. So with that in mind, this person suggested the idea of developing cislunar logistics. And LaserCom came across as a very important development, moving ahead from 20th century L-band, X-band capabilities. And my own mentor, Eb Breckton, would tell me that in space activities, loss of link equal to loss of mission. So it's very important that we include communications in our discussions. Several areas that we can use this at over time, and already the foundations are being laid for laser communications. We also thought that the Artemis Accords can be further strengthened using laser communications. Which brings us to a very interesting project from the architecture students. We wanted to talk a little bit more about the development of this Earth-Moon connection. So buscraft is an idea for a cislunar logistics cycler system that begins right away with existing infrastructure, existing vehicles. The Dragon capsule is fitted and flown to Leo to be what's called a plant and animal lab, PAL. And the idea is to look into radiation. So the first phase, we would send it to Leo, where you would check the robotic systems and the controls before we move it to deep space, into geostationary orbit. And there we would continue to monitor and get data back on how plants and animals behave in the radiation environment. 2023, we'll bring it back down to Leo, and then begins the setup for going to the moon. In 2024, we will assist the Artemis crew to go back to the moon by adding certain systems to it. And it can also serve as a rescue system if needed over time. So first we go into LEO, and then we would dock with the Orion craft so that we can service it over a period of time, and depending on the maintenance and whatever is needed to keep the animals safe and bring data back. 2023, we go into geostationary orbit and to continue with the experiments. So using the controls from LEO, we are able to verify what is happening in GSO. Then comes this very interesting chart. They are still revising it, but we'll shortly see how it comes out in February. Many of the assets are already in place, like the TDRIS. The LC already went up. And Starlink may play a role in communications. We are still working that out. We think the Falcon 9, Falcon Heavy, and Ariane can play a role. I'm of the opinion the Chinese Long March, the Indian PSLV, the Japanese vehicles, the H vehicles, can all play a role if we do things in low Earth orbit, as opposed to going to the moon and working with the very few, established players. So the most important thing that came around is that we should have a rescue capability in place before we begin many of these single string failure mode operations. Why would you go to the moon? In this administration, we think we should go to the moon because there are solar activity records on the moon that we can access, that we cannot access any place else in the solar system, not on Mars or further out. We think we can get this done here on the moon because it's a dormant body. And these are some observations on what buzzcraft can do. An idea is that orbital refueling is critical to do anything. As I think some of our earlier folks talked about, but modular clustering of propulsion is much easier to do than refueling as a moving fuel from one spacecraft to another. So that is about the Helios. How we go about it is still questionable. There are many things to do. It's an engineering question, but we know that these records are there on the moon. We just need to find out how to do it. One area to go to is the apertures that we know as skylights on different places. In this particular case, Tranquillitatis. I know that this student had read our earlier paper about going to Mare Tranquillitatis to go look at how the Apollo 11 site looks like after 50 years. In this idea, the idea was to put down a rover that is developed by Caltech and look down into the lava tube and sample the wall as you descend. Again, I was so happy to see Yushnoi present that the idea of rescue capability, which is very important, and a student presented some ideas on it, on how to do this. And emergencies come in a variety of ways and manners, and he exposed that to us. It's a long tail of emergencies. And we can also consider many of the vehicles, smaller vehicles, to support emergency activities. In conclusion, we all know, I keep showing you these all the time. I think it was in the last lecture too, about various people thinking about why we do these things. It all points down to planet Earth in the end. And there's the recent one, which I had not heard before, which was from Captain Kirk, William Shatner. He suggested that everything that we knew, know, do, talk about, and love is down there on planet Earth. And up is all dark and black. So we need to cherish planet Earth. Several technologies were presented, but climate change, again, came across as a very important thing to do. Species resilience. From several recent books, we know Mother Earth knows how to take care of herself. We need to take care of ourselves at the biosphere if we can. Brings up Jim Lovelock's point that adaptation is the best thing we can do, and space technologies are key to adaptation. I want to spend 1 minute. How much time have I got, John? Oh, nearly done. Okay. And when I was in school, a gentleman came and told us that he could build homes very cheap. We were all together at MIT studying in the International Space Universities program. So he comes over and says, I live in Southern California and I build stuff. And so when we came back to Southern California, I decided to visit him. And lo and behold, he was building these things. One day he calls me up and said, Madhu, you got to come there. And he put me in a spacesuit, walked around, could not do very much because it's very hot up there in the desert. But at the same time, we got an idea about how to do things with hand. It turned out to be what we call in-situ resource utilization. He had built a home out of the earth that it is sitting on. If you notice that the home is sitting in a depression, all the earth was built, put out, mixed with a little bit of cement, Portland cement, and built with the hand. This gentleman here is now in the ministry of the Kingdom of Saudi Arabia. That is George Whitesides over there. I think you know Virgin Galactic. So this gentleman, he came to class and he said, it was the year 2000. He comes and says, I would like to design a mosque on the moon. Lo and behold, that is exactly what he did in that class. And he went on to suggest that the faiths of various cultures are as important to society as anything else. So I had to quickly go and read up, and I'm still reading up on these matters. So he decided to show some structures. He bought the local imam, and it was quite an interesting time. And then I think is Maria on here? I thought I saw her.
I think Maria's on. I think Maria's on.
That's wonderful. This is a picture from when we were students, and this is Nasser, who is heading up the Moon Village Association's Moon Day, International Moon Day, and I'm so delighted. We should probably send him a set of these slides, John. And that's dear Maria there, and we are at the Smithsonian Observatory. That led me to think about what we should be doing on the moon. And here you see some earlier drawings on how culture, religion, and social activities, retirement facilities can happen on the moon over the long period of time. It started off right down the middle here by putting down a library of sorts. In this particular case, it was designed to be the Clinton Presidential Library, for which I got a nice handwritten note from the president. We are still working out the details of what we should do on the moon over a long period of time. In the end, I would like to tell you that if we do the things right on the moon, it can be, the moon can mirror and provide information to very clean living on planet Earth. And this is something that we've been pondering at the Moon Village Association too. Collaboration, and at the same time telling us the moon is an ambassador for the whole globe. It comes up every day, unlike New York, the United Nations, so on, that nobody can see. The moon is out there, and we can use it as an ambassador of goodwill for the whole world to do all these wonderful things. Please go take a look at our site, and thank you very much. In case you're wondering why I put this slide up, this is a very, very small piece of Omega Centauri and the globular cluster. It was shot by Hubble, and I enjoy viewing the skies and looking at these beautiful things, which is where the real life and the real happenings of our universe are going on 24/7. Yeah, I want to project that the moon can make us a better species, a globally cohesive species, particularly in this time. I'm happy to see the whole world working towards that in our discussions in the Moon Village Association. Thank you, John.
Thank you, Madhu. That was terrific. And if you wouldn't mind stopping the share screen.
There we go.
Thank you. Just one moment. I just want to mention again today's agenda. I apologize, Madhu. I started the recording for today's session just a few moments after the start of the session, and so I missed the very beginning of your remarks. I sincerely apologize.
That's okay.
I got distracted making myself a cup of coffee. I apologize. But at any event, so this is today's agenda. This morning, some additional technical discussions and presentations, and then after the break, then we'll have a panel discussion and some discussion of outreach and a synthesis of the event, and then the meeting will close. Madhu, thank you so much. I will just mention that next week I am actually scheduled to be in Riyadh speaking at a conference called LEAP, has to do with the leap toward the future. If anyone happens to be in Saudi Arabia, please come to the event. But I'm planning to get together with Nasser while I'm there.
Okay.
And I'll just promote for shamelessly for just a second the new International Moon Day, which was proposed by the Moon Village Association last winter, was accepted by the UN Committee on the Peaceful Uses of Outer Space last summer, and was approved by the General Assembly last month. And so now officially a UN event will be every year on July 20th, a celebration of International Moon Day.
Excellent.
And the Moon Village Association is setting up a separate organization, initially as a part of the MVA, but later it will spin off. The first chair of that organization is Nasser, the gentleman that Madhu mentioned a few moments ago. He's an excellent candidate, and we are hoping that all of you and that organizations that are interested in the moon around the world will in fact celebrate humanity first touching the moon and humanity's future on the moon on July 20th with events local and global. So with that, let me turn the podium over to Masato Sakurai of JAXA, who will be speaking on, I believe, on the subject that Madhu mentioned a moment ago, having to do with lava tubes. So please, Masato-san.
Thank you very much. Can you see my slides?
That looks excellent. Thank you.
Thank you very much. I would like to thank you for giving me the chance to speak here today. My name is Masato Sakurai. I measure Epirus. Today I will talk about rubber tube moon base. Lunar vertical hole underground. Sorry. The vertical hole and underground cavities are the most promising candidate for manned lunar base because the arrow long-term states of humankind from the viewpoint of radiation and temperature, utilizing this underground cavity. Utilization. The uncorrupted underground. Sorry. And this is a rubber tube, and here is the position of rubber lunar vertical hole. So the location lunar surface or in orbit. So radiation is severe on the surface of lunar, while vertical hole underground cavity is safe, almost there. Meteorites, lunar surface is considerable danger, and vertical hole is safe from impact. Temperature is surface is very large fluctuation. This figure, red point is in the night, minus 170 degree, in the noon, 110 degree. While this blue point, temperature is in the night, minus 20 degree to 30 degree. And construction material is thick shielding and pressure resistant structure is necessary on the surface, while vertical hole only air tightness is required. Other thing is the construction is time consuming, while vertical hole is use natural holes with minimum modification.
We lost your share screen for the moment.
Sorry. So this is an illustration of lunar vertical hole moon base. This is a vertical hole, and I think everything underground because the temperature is stable, no radiation, no meteorite. Problem is how to get energy during nighttime. We think one is a solar panel. Second is a solar power satellite, SSPS. Stay in the Lagrange point and on the surface receiving the power. And another option is atomic energy, and another option is gravity power storage device that put regolith in the box and raise and downs. So vertical hole have a 50 meter or 100 meter depth. So gravity potential change to electrical energy like that. And this area is a living area or agriculture area. And another side area is a facility, industry area. This is a molten electrolysis cell that composite electrical such magnesium, silicon, titanium from regolith. And this is a line that receives regolith from here to the send it to the facility, a tank that stores oxygen extracted from regolith. And this is a geothermal heat pump facility because underground is a very stable temperature. This is a lunar surface and underground conversion. If 0.6 meter regolith thickness for conatory size module, it takes 600 ton covered with module by regolith. So red point is this type panel sheeting. This orange type is sandbag shielding. And the pressurized volume lunar surface with shield. So for cubic meter, 133 kilogram is necessary. While underground cavity is unshielding, just inflator, 1/10 lighter than shielding. The waste heat is heat exchange is 1 kilowatt for 221 kilogram. While underground cavity temperature is stable, so light 1/5 the weight, 4 kilogram for kilowatt. And we make this kind of roadmap and discussion about the agriculture on the lunar surface. And robot is also discussion. And the construction is this is the idea of Taisei Corporation under the vertical hole. This is agriculture and green area. This is a living area. So we discussed. And the energy. So if we use sunlight and hydrogen fuel cell, And we calculated 100 people living need 3,000 kilowatt. It takes 891 ton. While if we use sunlight and gravitational storage, it takes 7,900 tons. And this is a nuclear power, 61 matrix ton. Laser type SSPS, 23 in orbit, 27 lunar surface facility. So in this case study, nuclear power or laser type SSPS is not bad. So we study SSPS, this type. JAXA study SSPS for a long time. And we calculate the seasonal variation or effect of corrosion like that. And this one is a German company, Energy Belt gravity power simulation. So I would like to show you video. So this company tried to change gravitational potential to the electrical energy. In this very heavy block, going down electrical generation, generate electrical power, and we can produce electrical power by gravity potential. So, and natural resources. So we discuss about the lunar base by using the vertical hole and lava tube. Our working group member is making a space vision, the Japan Society for Aeronautical and Space Sciences. And that's all. Thank you very much.
Thank you very much. Very interesting.
Thank you.
I did have one question. I know that you said that you were going to dispose of thermal waste heat into the ground because the ground is very stable.
Yes.
However, all of the objects in the tube are heat sources.
Yeah.
And they're all surrounded by vacuum except where they touch the lunar regolith. And
That's
the
right.
lunar regolith is an excellent insulator, very high R value.
Yeah.
And so I'm just wondering, how detailed are the thermal studies?
Yeah, we have a discussion. That's a very good point. Lunar is a very high vacuum, and Legoris is a
Excellent insulator.
Excellent isolator. So, in my sense, maybe a kind of liquid, ion liquid. Ion liquid is a no vapor. So, we study about 100 people living underground, maybe a lot of waste produced. So make some liquid, ion liquid by waste, and heat transportation is depend on ion liquid.
Okay.
That's
Yeah.
the
So I would only observe, I've said this in many of my classes I teach, that the second law of thermodynamics is the voice of God, but you must listen because you cannot escape from the second law of thermodynamics in the macro world, maybe in the quantum world, but not in the macro world. Anyway, thank you so much. That was a very interesting discussion. And just now we are almost exactly on time. And it is my pleasure to introduce our next speaker, Dr. John Rummel, who was for many years responsible for planetary protection at NASA. And these days is responsible for thinking about the future. So, Dr. Rummel.
Thank you, John. Let me see if I can get this machine to do what it's supposed to do. Something like that. So what I wanted to talk to you about today is life support systems and no way home without them. It's a proven, reliable system. The only one that we have actually is the Earth. It's bioregenerative, and it gives us what we want on a regular basis. But we don't go traipsing off across the cosmos without it.
John, we have no image as yet.
You have no
image. We cannot see your screen.
Okay, well, I'll see what I can do.
Now we see a goose.
Yeah, well, the goose is important. But if I do this, can you see both? That's the question. Can you see that image?
Not yet, John.
Sorry, yes, sorry. For some reason, when you go to the, I guess you're going to slideshow or you're going to full screen?
Slideshow.
Why don't you try full screen?
It's got a pause for some reason. Let me see what it says. Resume share.
Yep, you've got permission to share.
Yeah, I'm just trying to resume it. It's got it. Screen sharing is paused.
Hold on 1 second. I will shut you out. And then I will bring it back. That should reset you.
Can you see that?
Not yet. No, we don't have any share screen.
Okay. Well, apparently it's not happy with.
Well, we can get along. No, if you went back to where it was before, when we saw the goose, but it wasn't on the slideshow mode, that was okay.
How's that work?
Still, nope, we're not seeing anything. John, did you send me your presentation?
Yes, I did.
So let me look and see if I can download it quickly.
Your screen is back, John. You can see the first.
Oh, is it
title
back?
slide.
Oh, very good. Excellent.
So it says I'm screen sharing. Question is,
Yeah, you
Yeah,
are,
let
and we can see it now, but maybe don't try to go to full screen.
okay. I won't. Anyway, what I like to talk to you about today is a life support system, which has got to work all the time. And the only one that we have is the Earth currently. And we're going to do the best we can with that. But if we move off, let's see whether or not it will allow me to do this. To quote Freeman Dyson, permanent human settlement away from the Earth only makes sense if it's part of a bigger enterprise and the permanent expansion of life as a whole. It can also tell you if you don't expand certain aspects of life, it's not going to work. Logistic resupply is a wonderful thing if you're not on the receiving end of something that doesn't come. The life support system that I'm talking about looks something like this. And of course, it's an interesting concept that this is a life support system, but believe me, it is. But it's got a number of features that are kind of tough to meet in space. The ocean's the hardest one. Recycling of the crust by subduction and volcanism is also not very compatible with space activities. The edible plant growth, fish, you don't usually worry about your goslings getting eaten by a northern pike, but by a hungry astronaut, you can see that. And sun, after all, is something, the energy source that you can have in space, but this is Canada, so I have to add it in. And then humans are who we want to support. It's a lot to pack in, even in a colony like this. Envision for L5, the Earth Moon L5. So we have to understand the life support problem. And John, a couple of years ago, you gave a nice presentation on this at the IAC. But basically, thousands of kilograms per person year have to be supplied. Not only that, but you have to provide new polo shirts for the crew on a regular basis, which might be part of the life support system that people worry about too much. But we have to worry about things that have to do with water, including washing and other things. So the origins of the controlled ecological life support system is really with a guy by the name of Joseph Priestley. And he's a chemist in Britain. And what he found out is that if you put a sprig of mint in with a mouse, the mouse didn't die. Now, this could have been an early case of suicide if the mouse had eaten the mint. But bottom line is that the sprig of mint renewed the air and allowed the mice to live. Apparatus like this are the kind of things that Priestley worked with. There's that happy smiling face of Joseph Priestley in the upper left-hand corner. But the mouse lived, and it lived because of photosynthesis. And I usually go over this because I found out that very learned people have no idea where the oxygen comes from in photosynthetic reaction. It doesn't come from the carbon dioxide, even though that's what Moxie is doing on Mars. It comes from splitting water with the low energy capabilities provided by the chlorophyll molecule in the Z scheme. You release the oxygen, it's a waste gas, and you add the hydrogen onto carbon dioxide, and you end up with sugars that can be used for a lot of things. But if you get this wrong, you end up like Gentry Lee did with a little pile of carbon underneath his simulated Rama photosynthetic device. And it doesn't have to work like that. We like the waste gas, and we use it as an energy acceptor. And one of the things that we've noticed is that with the appropriate kind of farming, you can get yields that are much, much greater than the world record yield in the field. And that capability of overgrowing things that will support astronaut health, in this case wheat, you find that this can all be done within the amount of space available. This is an advanced CO2 removal technology. Not only it removes CO2 from the air, but it provides for low energy electrolysis of hydrogen hydrogen oxide. And the water splits, the lettuce grows, and you can eat the worn out pieces of removal technology, which is something that a lot of things can't be done. Scale is an important factor. This is the biomass production chamber at Kennedy Space Center and Bill Knott in the middle. They did some remarkable yields and developed some new yeast or wheat strains. Eucora rojo is one of the more interesting ones because it grows very short, but provides lots of wheat. Additional benefits, of course, is that not only Mark Watney got to have psychological and mission operations benefits, but Valentin Lebedev pointed out that back in the day when they were working on Salyut 7, the astronauts were very happy to eat that onion that you see on the right side of the screen. They reported on it for several weeks before they had to come clean and mention that they had eaten it. Drivers for our plant-based systems, reducing the whole overall cost, different varieties suited for space, test gravity independent growing procedures. The veggie machine that's on the International Space Station has demonstrated you can get chili peppers and a variety of other things that are space adapted. What's humorous about that is, of course, we started developing a salad machine back in the late 1980s, early 1990s. And it only took until just 2-3 years ago to actually fly it in space. We have to do better than that. But turning human and plant waste into plant food is the key to the future of a controlled ecological life support system with long duration stays in space. So the principles, how would you use this? Closed loop systems whenever practicable to reduce logistics. Open loop systems whenever power, mass, volume, and operational requirements dictate. Or where development timelines preclude the use of a closed loop system. You can still add a processor like the veggie system, which will produce oxygen and transpire water regardless of whether you want it to. But the key to a successful system is understand that you can turn plants on, you can turn plants off, but once you turn them off, you can't turn them on again. So for habitats and long duration transfer vehicles, providing for system growth and evolution is also an important factor. So this is your typical, little picture of a controlled ecological life support system. Green plants providing the benefits that they do on Earth as we would like them to do in space. Lunar regolith can be transferred into a controlled ecological life support system in certain parts. Sometimes you can envision that you'll find the appropriate bacterial capabilities that will deal with things like ilmenite or iron oxides. But all of that is potentially addable to this small document. So you can go ahead and do that. Now, of course, you can make it much more complicated than it is. This is NASA's 1991 initial reference configuration for a controlled ecological life support system. And the idea of this document was to start taking things out of it more than adding things to it. It's not dissimilar to the current International Space Station life support system with plants added onto it and a variety of other biological processors. If you get big enough and the system size grows, extrinsic controls have to give way to intrinsic control mechanisms. So ecology becomes very important in this because you can only affect certain kinds of things. You're not going to be able to walk up to one of those spruce trees that you see in the background and turn an on and off switch on that. So we have to learn a little bit about how closed environmental systems work and hope to do that in a place like L5. A couple of papers I'd like to recommend. One is Alex Ellery's Supplementing Closed Ecological Life Support Systems with In-Situ Resources. An interesting take, very detailed in the kinds of things that can be added to a controlled ecological life support system. And then a very nice review by Hong Liu and his colleagues on the research in the bioregenerative life support system. A great history there, incomplete as most histories have to be, but still a very useful resource. We'd like to show in the Moon Village Association something as compelling as this, but I tell you, if I were going to be depending on seeds or on crops, I wouldn't put them out in the open. I wouldn't stop worrying about radiation. I think that our previous speaker, Seto-san, pointed out that there are some very nice opportunities out there. Ellery will tell you that extensive shielding will be required and pipe sunlight will be necessary to go ahead and have a bioregenerative life support system on the moon. And only a small fraction of the water that's required is going to be from lunar materials. You can go ahead and recycle water, however, very efficiently in these systems. Water is filtered through the roots and comes out stomata, and it's very clean when it does. Lunar regolith can be exploited for multiple roles. And visible spectrum light could be delivered via fiber optic cables to light a lunar greenhouse, whether or not on the surface or in a cave. You could also look at regenerative fuel cells, and this is all made much easier than it was at the time with light emitting diodes for your light sources. In a place like Antarctica, they're testing these things out. It's Concordia Station. And of course, if you go to the US Scott Amundsen Station, you'll find that the most popular room at the South Pole is where they grow the crops. And they grow the crops to supplement the food sources available there. And this image is taken from a seat that they have. They actually have a table and 2 chairs set up and people book it so that they can have dinner at the greenhouse. Mission assessments, initial lunar surface and gateway, physical chemical only. Later, Lunar had a salad machine and bioregeneration. Long duration stays on the moon enable a high degree of testbed capability. Mars transit, Mars exploration. You add bioregeneration as you can, and eventually the tourists who are on the moon or on Mars are going to want to know what they're going to eat on the way home. And you better be able to show them something. One of the things I feel responsible to do is to point out that the difficulties of actually harvesting ice and making rocket fuel and shipping it off in something like a accelerator is very difficult. Here's the Kaguya image of Shackleton crater, 90 degrees Kelvin. One of the things that you find is that it's very difficult to see any evidence of ice in a picture like this. So you know you're going to have to dig when you get there. And the question is how deep and in what form are you going to find the ice? But what future would you have? A lunar mass driver provides transportation of resources to low Earth orbit, and that'd be happy days. But who operates the mass driver? If you have not read The Moon is a Harsh Mistress, we showed. 16-inch gun projectiles with high explosive rounds on point to hawk to look like the image in the lower right. If you send something about the size of my 2-year-old daughter, you get a very high energetic impact on the Earth when you do it from the moon. And I'm not sure I want everybody I know to have access to a lunar mass driver. Thank you.
Thank you, John. And if you would stop screen sharing.
Well, no, that's
Excellent, excellent. We are just a moment or two ahead, so we have a little time. Would anyone like to ask a question of Dr. Rummel?
John, I would love to have access to that mass driver. Just kidding. Thank you for a great talk.
Thank you, Madam. I appreciated your entry, and I'd love to have your students interact on these questions that come up. So, and my 2-year-old daughter is asleep, so it's okay. I'm not going to put her in a lunar mass driver anytime soon.
That's probably for the best.
Yeah, it's warmer here than it is where you are, John.
That's good. So I have a I will indulge in one question, John. With the data that go with the research results that you presented concerning increased productivity from a particular crop, from a grain, I think it was. Can you provide the reference? Because I'm interested in the associated CO2 levels in the air, CO2 consumption associated with that yield rate, the energy balance, the nutrients, and so on, i.e. what's the balance of system for a case where you've got those very high plant yields.
So, yeah, if you go to that slide, the reference from the proceedings of the National Academy of Sciences is on the slide. So you should be able to find that. If you want to go into some of the details of how that goes and how low the carbon dioxide levels can go, there's a good paper out there by Ray Wheeler who can tell you about that. He's got one thing definitely wrong in his paper is he misjudged the year that I took a bunch of people to the BIOS facility in Krasnoyarsk, which was 1990. But essentially the carbon dioxide levels go down to almost nil. And you have to supplement with carbon dioxide to be able to continue to grow the plants.
That's what I would have expected. I'm just looking for the numbers so that I can get a feeling on the overall system model that goes with those yield results. So
yeah,
anyway,
the yield results in this case are available at the paper that's cited.
fabulous. Thank you so much. Any other question for Dr. Rummel? Yes, Masato-san. Masato-san, sorry.
Thank you, John. Very interesting presentation. So you talk about sales. So in Japan, we have also a sales system in Rokkasho Village. We call it CEF, Closed Ecological Experimental Facility. Do you know it?
So there's been some excellent work that's been done since I actually departed this part of the field a number of years ago, aside from being on the side and waving people on.
Yes, thank you very much. And yeah, and the CEF
I look forward to your crop choices as well as to your excellent technical work.
Thank you very much. And the CEF have a problem about waste disposal. CEF choice wet oxidation.
When I did work with Tyler Volk on this back in the 1980s, one of the things that we used was very high pressure waste, basically what was called supercritical water oxidation.
That's right.
We got rid of all the waste.
Yes.
And turned it into useful material. There are a variety of different techniques that people use, including feeding things to tilapia, the fish, and a number of bacterial columns, et cetera, that people have to try to get more useful waste products than just the nitric acid and things that we got with the supercritical water oxidation. And there are a number of things that don't cycle very well, salts and other things, but still can be used as a way to take in a waste stream. But my concern on this whole system has always been waste processing. Easy to grow wheat, difficult to do something with what's left over.
Yes.
Yeah.
Thank you.
Okay, thank you, John. So let me ask, is Bernard Fong with us at the moment? And I don't see him at this time. I'll send him an email while we're on the line. So if I may ask, it's a little bit early, but still, is Sato-san Naoki from ISIG, are you with us at this moment?
Yes, I'm here. Can you hear me?
I can hear you just fine. Would you mind, please, doing your presentation now out of order while I see what's happened to Bernard?
Okay, I can do that.
Thank you so much.
Just a moment, please. Okay, can you see my presentation?
Yes, yes, it looks great.
Okay, let me start my presentation. But anyways, thank you very much for inviting me to this workshop. And my name is Naoki Sato, co-chair of the International Architecture Working Group of the International Space Exploration Working Group, ISIG. I hope you are aware of ISIG, but ISIG is a voluntary group to discuss the future space exploration plan and objectives. And currently, we are now 27 agencies group, and still we are discussing the future roadmap and operation scenario of the surface exploration. So I'm just going to introduce the global exploration roadmap, which the ISIG is mainly working on. So at first, on the 2007, we have developed a global exploration strategy. And based on this one, the ISIG was formulated. And in 2011, we have developed the first global exploration roadmap. And then we have been revising in 2 years or 3 years time frame. And the last one is GR 2018. We call it the GR3. But based on this one, we have published GR Supplement 2020, which is very focused on the lunar surface exploration scenario and objectives. So I'm going to introduce the GR Supplement first. And the very important point of this GR Supplement is to develop a very detailed objectives of the lunar surface exploration. As you can see here, you can see the very high-level goals in the upper line. But this is just high-level goals. But the important point is that based on these goals, we have developed very detailed objectives, as you can see here. So, for example, the first one is to demonstrate the human landing and ascent capability to and from the lunar surface. And you can see in the very right-hand side, you can see the performance measure target of this of each objectives. So for these objectives, our target is to landing and or ascent the 4 crew. And I think you should be very interested in the rationale for these objectives. So for this technology demonstration, for the rationale is to mitigate the risk for the future human Mars exploration, but also for the future government activities and the commercial markets on the lunar surface. I believe the Moon Village is targeting on this long-range lunar surface activities, including commercial markets. So this objective is very related to the such long-term lunar surface activities. And also the second one is to demonstrate a range of cargo delivery capabilities to lunar surface. And performance measure target is 9 tons for large cargo transfer, and 1 ton for the small or medium landers. And the third one is demonstrate the EVA capability to also to mitigate the risk for future human Mars mission and also the sustainable lunar activities. And the fourth one is to demonstrate the human long-range traverse capability on the lunar surface. This is to talk about the pressurized rover, which currently Japan is going to develop, and the performance measure target is 10,000 kilometers in cumulative. And the next one is demonstrate reliability of human long duration habitation capability. The major performance measure target is 500 days in cumulative. And the next one is to demonstrate the crew health and performance sustainability to live and work on the lunar surface. And the performance measure target is still TBD, and we are still discussing what is the most appropriate target should be. And the second one is demonstrate the ISRU capability for the crew transportation between lunar surface and the gateway. And our target is to produce a 50-ton propellant per year to transport the crew between the lunar surface and the gateway. And next one is to conduct science. So I think we don't need to talk about more. And the next one is develop infrastructure such as the power and the communication system. Target is 300 kilowatt for power and 1 Gbps for data transfer between the Moon and the Earth. And the other one is a more generic one to engage the public, especially for the young youth. The target is still being discussed, but for example, we are going to measure the positive public attitude, such as more than 30 or 50%. And second to last is to implement a new commercial arrangement. And our target to increase the number of commercial partners year by year. The last one is to provide a large number of collaboration opportunity for international partners. Our target is to get more than 100 nations participation to the surface. These are the goal objectives to be implemented by the 2030 or 40 timeframe. So this is the long span roadmap of the ISFG. The phase 1 is put on the Moon in the first landing of the astronaut in this century. and by providing the gateway and providing the human lunar lander and the EVA suit. After that, we are going to increasingly provide the lunar surface asset, such as the unpressurized rover and the small pressurized rover, and cargo landers, and the small habitation here, and the power elements. And during these days, the ISR demonstration will be conducted, and the pilot plant, and in the phase 2B, which is more Mars forward and ISR focused phase, we going to have a ISR plant, actual plant, and also the long duration habitat. So as you can see here, we are not going to provide a big lunar base, but rather small elements, because we are going to just demonstrate technology for future Mars mission and also the sustainable lunar activities. The area we are going to go is basically the South Pole region, as you can see here. But in the latter phase 2A, that means 2035 to 2040 timeframe, we are going to offer the pole, such as Schrödinger Basin or Antoniadi or South Pole Aitken Basin, to get more scientific achievement. And this is the final image in the end of phase 2, actually phase 2B. So you can see all the elements I have mentioned here, but again, that this is not so big lunar base. So this is the how the objectives will be achieved along with the phases. So, for example, the demonstration of the human landing as ascent capability in the phase 1, it's only 2, but during the phase 2, we are going to increase to 4. And for the demonstration of the traversing capability, there's very little in the phase 1, and in the phase 2, we are going to increase the capability from the 1,000 kilometer to 10,000 kilometer range in the phase 2. But anyway, I'd like to emphasize that we are going to complete these, accomplish these objectives within the phase 1 and phase 2. And our concept is that the phase 3 will be the sustained lunar activities by commercial companies. So again, in the phase 3, the sustained lunar opportunities, and we believe that the capability demonstrated by the phase 2, such as long duration habitation operations and commercial development, mobility system, and ISR production operation, will aid sustainable lunar surface economy in phase 3. And also the access to and from the lunar surface need to be more commonplace and affordable before the phase 3 or during phase 3. And in parallel with phase 3 on the lunar surface, the governments would shift their investment focus to support the exploring other frontiers, including Mars. And we also developing the lunar surface concept of operations, as you can see here. So the process is to define first the operation approach trade space and pros and cons, and select the correct current approach, and set the ground rules and assumptions, and draft the concept operation based on the approach and ground rules and assumptions. And then we derive the function allocation for each element, and also identify the contingency case and also the function allocation for this contingency case. And that's all my presentation.
Thank you very much, Sato-san. That's very, very interesting. And I think this slide showing all of the many organizations that are involved in the ISIG-G is probably one of the most compelling images of humanity. We're going back to the moon, continuing out to the moon. So I think
Yes.
it's that set of icons is extremely
Yes.
powerful.
Yes, yes.
So we have time for a question or two. If you would like to maybe stop the share screen. Thank you. So if I may, I know that the CNSA and the Roscosmos are members of the ISIG-G, and after the August 2020 update, global exploration roadmap update, in the summer of last year, CNSA and Roscosmos announced that they are going to pursue the International Lunar Research Station, including some new combination of orbital and surface assets with some fairly ambitious goals. I'm just curious, within the framework of the ISIG-G, can you maybe just describe how are these new plans presented by CNSA and Roscosmos, how are they being, I would say, digested? How are they being incorporated into the ISIG-G discussions?
Okay, that's a very good question. So I believe yeah, it's kind of the back and forth process. So we have provided our thought and concept as the GR supplement, and because the reason why we are now developing such a GR is to show the kind of reference of the international from the international group, and then our concept is that each country get back to their government with this reference, but they can they're not necessary to be consistent with this reference. This is just a reference, so each government will decide how to implement this reference. So I believe that the Chinese and Russia's idea is just to implement this our objectives and roadmap by their own purpose and by their own process.
Yeah, very interesting. So will another question, if I may, will there be an update of or further elaboration of the global exploration roadmap anytime soon?
Yes, sorry, I forgot to mention, but yes, that's true. We are now working on the updates, the GR supplement, and our plan is to release the new supplement in summer time frame this year.
Oh, excellent. Very, very interesting. Thank you. Would anyone else like to ask a question? Well, if not, then please forgive me. I have just one last question because we have a little time.
Sure.
One topic that is of great interest in all of the discussions we had during the first 2 days is the questions involving lunar construction and lunar ISRU, in particular the propellant production, and of course back behind those functions there is the question of energy, of power for ISRU, and power for fabricating structural systems from the lunar regolith, or for processing the lunar regolith to extract critical materials for life support and so on. And I know for the most part, the GER does not have a lot of emphasis on, for example, there's no objective for the construction of a pressure vessel, that kind of thing. But there is for the production of propellant. And I'm just curious, how in the, and these things are very important, of course, in the ongoing Moon Village studies, and in the evolution team study within Japan and so on. So it's very critical for a lot of a longer term interest. I'm just curious, how are these subjects, so lunar surface construction and fabrication, ISRU and the processing of the lunar regolith, water extraction and processing, energy and so on, these things come together. How are they being treated within the ISIG-G?
Okay, so I think we have already treating the 2 of 3, so ISRU and the power. So our objective is for the power to produce around 300 kilowatt power on the lunar surface. That is very related to the ISRU, because the water extraction and liquefaction is requiring very much power. So that's why our target is 300 kilowatt to produce enough fuel for the lunar crew transportation between a gateway and the lunar surface. So we have already touched on the ISRU and the power, but we have not touched on the construction, because construction itself is not so much related to the Mars forward. So that's why we have not touched on that. But yeah, I think for the more powerful lunar base, I believe that should be that kind of technology should be developed and demonstrated. So that is the further topic for us too.
Yeah. Okay. Thank you very much.
John, I had one more question.
Please.
Thank you so much, Naoki. It's a very, very interesting set of slides. There is a focus on our community, and to look only at the South Polar region. I think we are partially the perpetrators of it. And what in the master plan or in the global exploration plan do you have for the global exploration of the lunar surface?
Yes, so we are still discussing the within ISIG-G, and yes, as I mentioned, we are just off the pole, go off the pole, but currently there is little there is little opinion from our members to go more global exploration. So if there is such a strong opinion from the members or from your side, we can discuss about that.
One area is obviously lava tube exploration, and we don't have signs of any of that in the polar regions. So that may be something to think about. Thank you so much for a great presentation.
Yeah.
Thank you for your opinion. Thank you.
And if I may, I had one question from one of the members of the workshop, one of the participants of the workshop this morning. I wanted to, this morning in California, obviously, late evening in Japan. I apologize again.
No problem.
So one of the key subjects that the Moon Village Association is looking at, and we're just curious, how is it being dealt with within the discussions and the roadmaps, the planning of ISIC-G and the ISIC-G members, is the subject of interoperability among the many systems and the types of interfaces. Clearly, we know there's a strong heritage for the gateway from the International Space Station partners and ISS systems, but for the moon, the lunar surface, the transportation systems, the ISIC-G partners, it's much bigger than that. And so how is both the technical and the I'll say the interorganizational, all these issues having to do with interoperability, how is this being treated?
Okay, yes, we have noted such interoperability or standardization is very important, and I think those are kept in our high-level objectives or goals, but we have not discussed so much in detail, technically, and I believe that this the interoperability or standardization will be implemented along as the actual implementation or development by the agencies.
Yeah. So it's accepted as a goal, but
Yes.
but it's not really a topic within the discussions of the ISIC-G. It's assumed that it'll be dealt with by individual agencies and programs and so on. Right. Okay. Very interesting. Any other questions or discussion for Sato-san? I very much appreciate your being willing to engage in such extended conversation. It's extremely informative and very helpful for us. Oh, Dallas Bienhoff has a question. Please, Dallas.
Yes, John, and Naoki, thank you. I wonder if the roadmap has a population curve or a population on the surface curve in your thinking from phase A to phase 1 to phase 3. How many people on the surface
population
over time?
Yeah. During phase 1 and phase 2, it's just 4.
Just
phase 1 is
4.
2. Phase 1 is 2, and the phase 2 will be increased from 2 to 4.
Okay. And in phase 3?
We haven't discussed yet.
Okay, thank you.
Very good. And we also had a question from Rodrigo.
Yes, hello everyone. People that are working in less advanced space matters countries, I would say that we strongly need some standardization. In several things. I mean, to unify the measurement systems, MKS or whatever, and also to limit the size options of fixing elements, pipes, cables, etc., electrical resistance, frequencies to use, kind of communication systems, etc. even to consider the use of adapters to access measurements used by other users, etc. And we also are concerned about the building of things in the moon, on the moon, or I would say under the surface on the moon principally. Are you considering to use the structure of the rockets that we're sending instead of let them came back to the Earth? I mean, once you made the efforts to put a very big, strong structure in the space, maybe it can continue the way to the moon and to be used after that for other kind of things, like a building or things like that. What do you think about that? Thank you.
For this construction structure on the lunar surface, we haven't discussed so much because as I said, our goal is to go to Mars eventually. So currently we haven't discussed so much about that.
Yeah, very interesting. Thank you, Rodrigo. Very good question, and one that we should take up in the MVA working group. So,
John, excuse me, Oleg Vinskovsky speaking.
Yes, Oleg. Good morning or good afternoon.
Just good morning, good afternoon. Yes, just a quick reaction to the question by Rodrigo. Rodrigo, my company, Yuzhnoye Design Office, came up some 5-7 years ago with the concept of the so-called lunar research and development and industrial base. And responding to your question, yes, indeed, in the frame of our studies, we have considered the possibility to use, for example, cost structures of some of the rocket stages as a basis for creation settlement on the moon, because it's well protected, especially if you put it with some layer of regolith. It's already a carcass, a basis of one of the possible buildings over there. So it's on our radar, and if you are interested, we can probably share some information with you.
Okay, thank you very much.
Yeah, that would be very helpful, and I would be very interested also, Oleg.
Okay, John.
Thank you so much. So I've followed up with Bernard by email. He had RSVP'd that he was going to be able, and he was planning to participate today, but unfortunately, I'm just getting an out of office reply, so I think he will not be joining us. Luckily, this wonderful conversation with Sato-san has really been both informative, and it has critically gotten us back on schedule. So we had planned to take our break at 6:50 a.m. California time. It is now 6:49, and so let's go ahead and break now. If Bernard does end up joining us later, then we will certainly accommodate him. But otherwise, let's try to reconvene. And when we reconvene, we're going to continue this discussion of the activities and interests and how better to engage emerging space countries with a panel discussion led by Ghanem Alotaibi, who is the head of the Moon Village Association's program for emerging space countries, PESC. So for now, let's take a break, get some coffee, in my case, or sake, if it's Sato-san's case. And
thank you. Yes.
We will reconvene in about 10 minutes. Thank you. See you then.
Thank you. Bye.
Good morning again to everyone from California. We're going to get started in just a few moments. I'm waiting for my my tea water to boil, which it's getting very close to, but it's going to be just a second, and that'll give others a few more moments as well. So please give me about 1 more minute.
Well, if your tea water was on Mars, it would be boiling, but it would be very cool.
And you're kind of pointless with regard to the infusion, but nevertheless.
It's good to see that John is also a tea drinker. John, we're all the tea drinking community, I think.
Absolutely. I drink different particular teas at different times of the day and for different situations.
Okay.
This morning and most mornings, Earl Grey.
Oh, is it right? Okay.
Bergamot is an acquired taste, but I have acquired it.
So I think you guys have just come up with a new project for MVA, the tea project. And
there's no point in going to the moon or Mars unless there's tea. And bourbon, of course, but sorry.
Yeah, John, out there by San Rafael is a company that makes some fine teas. And the one that I've been using for a while now is a black tea called Mighty Leaf. They serve it on some flights too. So if you like black tea at some time of the day, you may want to give it a try.
I always drink the gray tea, Earl Grey tea.
You like Earl Grey? Okay.
But I think your suggestion is an excellent one.
Okay. Let me thank everyone for their patience. My Earl Grey tea is now poured and steeped, and I would like to return us to our discussion of the future of humanity and the moon, and in particular, next in our agenda will be a panel discussion as we close towards the end of this workshop. It will be a panel discussion led by Ghanem Alotaibi. I got a typo there. I apologize. That should be an I. I'll fix it later. Sorry, Ghanem. Leading a discussion with members of the Program for Emerging Space Countries within the MVA. Ghanem, the floor is yours, and please introduce yourself and the panelists.
Sure. Thank you, John and Maddo, for this opportunity. Of course, being part of the Moon Village Architecture Working Group is something important for BESC, because the roadmap, which is the most important document we have, is adapted from the white paper that was published in January 2020. And now we are updating BESC roadmaps based on the new version that was published a few months ago. So first of all, the plan was we will have 3 panelists, one panelist from Egypt, we will have Baha from Egypt, and we will have Rodrigo from Chile, and the plan also to have Sahba from Jordan. But unfortunately, due to urgent circumstances, Sahba will not be able to be with us. So we will have only 2 panelists with us. Before I go forward and introduce our panelists, I would like to share my screen and have only a few minutes introduction about BESC for those, for the participants in the event that they don't know what's BESC. So BESC is the participation of emerging space countries. My name is Ghanem Latebi, and I am the project manager of BESC, the participation of emerging space countries. I used to work in the oil industry for 6 years, and then I did my master thesis in Germany in solar energy and photovoltaics. Then I came back to Kuwait, and currently I am working in a small satellite project in Kuwait University. Before I get exposed to the Moon Village Association, I was also an active member in the Space Generation Advisory Council. So very quickly, I'm not going to spend a lot of time. So BESC is actually is an inspiration from the goal of the Moon Village Association. As you can see, this is the goal of the Moon Village Association, and I highlighted the keywords: global and interested in the development of the Moon Village. So in order to make the Moon Village Association a truly international effort, we will need to have the vast majority of the world population involved. And the vast majority of the world population are actually living in emerging space countries. So we believe that the world is progressing very fast toward the base in the lunar surface. And this is not a science fiction. The associated activities can open tremendous opportunities for everyone. Very quickly, we had the first activity for BESC in 2019. It was a pilot project in Kuwait before COVID, and then it was adapted by the Moon Village Association in 2020. In June 2020, we called for phase 1 teams. So we opened the call for teams representing their countries. They can apply, and they went through the different phases of the project. And as I mentioned just a moment ago, the most important document of the BESC is the roadmap. The roadmap was inspired, and we adapted in the BESC project, we adapted the white paper roadmap that was published by the Moon Village Architecture Working Group in January 2020. So each country are responsible, each team representing, of course, countries, and we have different teams. I'm going to discuss a little bit about the structure. Each team is responsible to come up with the roadmap, where they have to discuss some aspects mentioned in the white paper. For example, the different scenarios, building blocks of the roadmap, of the Moon Village, the building blocks of the Moon Village, and how they see their countries' capabilities and interests are intersecting with the building blocks of the Moon Village. Now we are updating the roadmaps with a new version, and we have a special consideration for the concepts of operations. So this is the structure of the BESC project. We call for teams, and then the teams start to work on their roadmap. We have template of the roadmap. They have to mention why it's important for their country, to be involved in the Moon Village based on the white paper produced by the Architecture Working Group, and how the Moon Village will be also benefited from such countries' activities, what are the partnerships. And then as they finalize the first draft of the roadmap, they start to approach customers and investors. So BESC teams are actually activists within their local environment in their country for the Moon Village. And the roadmap is a dynamic document. So when I mentioned that the roadmap will be updated based on the new published paper by the Architecture Working Group, this is the normal process. The roadmap should be updated all the time. This process will be repeated until the actual involvement of the countries. So what countries we have, as you can see here in the map, we really have many countries from all over the world, from Chile to Mauritius to Mongolia, Pakistan. Today, we will have countries, we will have Egypt and Chile. Of course, we have different teams representing different countries, and different teams means different structures. For example, the Egyptian case, the team from Egypt are highly related to the space agency. Egypt has a space agency, and they are interested in moon activities. In the case of Chile, there is no space agency. However, there are activities ongoing right now to establish a space agency, and there are some research activities regarding the moon. We wanted to have Jordan with us, but unfortunately, we couldn't. In the case of Jordan, we have an entirely independent group. There is no space agency, and they are all consist of young professionals. That's it for BESC right now. I will stop sharing screen, and I would like to ask Rodrigo and Baha. Let's start with Rodrigo to introduce themselves, and then we can start the discussion.
Thank you very much, Ganim. I'm Rodrigo Suarez. I am an aeronautical engineer. I was formed in the Chilean Air Force, and I worked there for 33 years. And I was part of our first satellite program, which was conducted by the Chilean Air Force. And that's the way I get into space or near the space working. So far, I mean, that was in 1994, 95, like that. Our first satellite was launched in 1998. And after a few years, we still have only Air Force conducted space programs, okay? We had a space agency and I was working on the creation on that in 2000, but now it's not working. So we, as Ganim said, we don't have any kind of agency. But I was working with the space. I continue working with space, and now I'm working the university, and I have made several courses for people in the area of remote sensing, and I am part of the board of the Agencia Chilena del Espacio. Perdón, excuse me, it's Chilean Association of Space, okay, which is not a government agency, but it's a non-profit organization that take together all or most of the professionals linked to space activities. And even we are not part of the government, we are helping government institutions to get into space. And what I mean is we are working with them on science affairs and things, and legal aspects, and educational aspect, etc. So for today, I am the first vice president of the ACHIDE, which is the name of our Asociación Chilena Asociación Chilena del Espacio. And we are starting to grow in space, but we still need the strong involvement of the government. Okay, so in Chile, this last 20 or 30 years, there have been several different initiatives coming from different parts. I mean, universities, some individuals, some enterprises, but we still need a governmental organization that can take care of all the space activities. So today I'm here because Loreto Moraga, which is our president of the Chile Association, she couldn't be here by this time, but we are open to MVA and to work with all other teams as good as we can, and we hope we could be a good part, or we could have a good offer for all the teams. So so that's it. And
thank you, thank you, Rodrigo, for this introduction. Baha, can you tell us a little bit about yourself?
Okay.
Yeah, hi, Ghanem. Okay. Hi, Ghanem. Thank you for having me. My name is Baha. I'm a research fellow at the Scale Lab at Brown University in the US. I'm currently the technical lead for the Moon Village Association activities in Egypt. We are currently working closely with the Egyptian Space Agency on a proposal for possible lunar exploration endeavor by the Space Agency. We managed to propose to the Egyptian Space Agency a scientific comprehensive proposal for scientific targets on the lunar surface for a possible mission if they wish to go through it. And we are currently on the verge on proposing a first-hand proposal for technical comprehensive design for a 3U satellite for such mission. That's it, basically, concerning technical studies, but we have done a lot of work concerning reach out to the local community and the international community through a lot of MVA events, online events. We hosted a lot of Egyptian Space Agency officials, and we are trying to engage as much as we can with the Egyptian community and the international community regarding space activities.
Thank you, Baha. Yes, as I mentioned, so our BESC teams are actually activists, and engagement with the community is part of what we are doing. And this is actually this is going to be the first question. As emerging space countries, we have, of course, different countries involved, some of them with space agencies, others without agencies. And the question here is actually one of the questions we had in our annual survey. And we found that in general, the participants of this survey, they answered positively. The question is, have you seen increased interest in moon activities within the public in your country, one level, and the other level, have you seen an interest among officials in the government in moon activities? And here I would like to ask Baha the question first. Baha, have you heard the question?
Yeah, I heard that.
Yeah.
So regarding that, I would like to answer first about the government level. On the government level, we have seen engagement on a lot of phases during our cooperation with the Egyptian Space Agency. We have seen highly expressed interest. We have found that firsthand during our engagements, especially with the head of the Egyptian Space Agency himself. He would engage with us in person during our proposals. So we are seeing a highly appreciated interest on a governmental level. On a public and local level, the Egyptian Space Agency have struck a lot of efforts in order to spread space knowledge and to make the public aware of the existence as well. We can see a lot of social media existence, a lot of attempts to attract Egyptians, not only on a local level, but Egyptians who have traveled internationally, studied internationally, worked at NASA, worked on other space agencies. They would make some online events and try to establish a talk in the native tongue and to engage the community there. We have seen also the Egyptian Space Agency trying to prepare an educational kit for the university there and try to establish a lot of internship opportunities inside of Egypt and outside of it. Actually, Space Agency is trying to expand their existence on the public social media. So there is a lot of engagement in the public. And we in Egypt, when we try to do cooperated and coordinated events through MVA and SGC, we would see that and it was international online events, we would see a high rate of Egyptian presence there and Middle Eastern presence. So that was an indicator for the public interest.
This is, of course, very exciting. I think we are living in a very exciting time right now because the increased interest in moon activities are seen not only in Egypt, but also in many other places in the world. And we can see that from our BESC activities. I would like to ask Rodrigo the same question, but I would like to emphasize on a question that one of the participants is asking by Richard. In addition to the interest of general public and the officials in Chile, does the Chilean mining industry show interest in the MVA Chilean space?
Okay, yes, thank you, Ganem. So then I will talk first about the official part. I want to tell you that the Chilean Air Force now is conducting a very big national satellite program with which they intend to involve all people in learning and studying issues related to space technology in general. And it was approved, and in the next 5 years we'll have something like 7 microsatellites and 3 mini satellites, a little bigger, and part of them will be built by Chilean students and professionals in general. So that is a very good and strong impulse that is given to the space industry in Chile. And in parallel, we as at Chile have been preparing legal documents to help the government to get involved in this space. I mean, we are already involved, like as a participant country of the treaties of United Nations, right? And we have a register of satellites and etc. But we are working on preparing a space law for Chile, and also a specific law to create a space agency. And we have in Chile a new ministry since a few years ago, which is called the Ministry of Science and Technology and Innovation. So we're working very jointly with them in all the things So I think that officially we will have a good infrastructure for supporting the space industry in the future. And in the general area, we can notice that people is taken in account, and they are talking in social media about all the new things that are happening in space, okay, in general. And I mean, SpaceX and plans to go to Mars, etc. And all that is going to be concentrated in a fair. We have an international air and space fair in Chile that this year is going to be done in the first days of April. And actually, it's a very, for us, a very old affair. I mean, it has been done many times. And they will have a specific hall for space. So I think all people is going to be involved more and more in this area. Now, concerning specifically about mining, we have in Chile, the Association of Chilean for the Space, we have been talking with our Chamber of Minery, which is another association that groups people from the minery with all the different companies. And together we have prepared plans for go into astrominery as soon as possible. And I think for this February or March, there will be very good news concerning that, because we want to get miners involved in space. And actually, the mining enterprise in Chile, the mining industry, is very interested in astrominery. And as far as we have a very strong legacy in mining in general, I know they are now interested in the undersea mining and also in astro mining. So the idea is that if we know or we start to work with astro mining, it will also help undersea mining and etc. And we have, I mean, we have had even some webinars concerning asteroid mining and things like that. So we are getting more and more involved each time.
Thank you, Rodrigo. As of course we are talking about engaging the public, we were really excited about the International Moon Day. In the BESC project, we are planning to do some activities in July, outreach activities. Again, this is part of what we are doing. And of course, we will invite all our countries' local teams to be part of this. Rodrigo, as an extension to your discussion, you touched the building blocks. And this is my next question. The roadmap that we produce in the BESC project is all about identifying capabilities and interest for your country, and identify links between those interests and the building blocks of the Moon Village as published by the Moon Village Architecture Working Group. You mentioned a little bit about the mining industry as one of the capabilities in Chile. Can you tell us more about other building blocks and how you see Chile can be participating in those building blocks?
Yes. Well, actually, as I told you, we still need a stronger participation of government. When we work on the roadmap for Chile, it was 2 years ago or something like that. There was almost nothing comparing with the situation we are living today. So in general, we are more involved, and I think that as time goes on, we can find more people interested in doing things concerning space. We have people working on different issues or projects. They are at a different pace of advance. Okay, there are some more quicker than others, but we are very strong working on architecture. And we have in my university, we have a group that works with extreme architecture, and they have prepared labs, self-standing labs that can be working in the Antarctic and also in the desert and big mountains. And so they are now strongly working on architecture for the underground in the moon. And that's why I asked the question some minutes before, because I understand that in Mars, there's also a lot of radiation, and they will have also to do something underground. But whatever, we have these people is working not only in the habitability on the moon, and they are thinking that together with mining on the moon. Okay, so and I have some. We have been talking about some ideas. The idea in the moon there are some caves underground, and the idea is to build things inside them and etc. But we have also people working on clothing. We have people. Oh, Bingtan, please. Can you? Yeah, good. We have the people that is working in clothing that is censored, okay, for people to be living on the moon. We have another team that is working on agriculture. They are making a self-sustained habitacles. I mean, they put a plant and some things in a closed capsule, and it survives, I mean, indefinitely so far. So they're working on those kind of things. And of course, we're working on we have another team that is concerned with mining operations on the moon. And we have another team that is working on a radio telescope to be put on the Shackleton crater. And I am actually working with a vehicle. I mean, sometimes I feel people laughing about this, but we want to create a set of little light vehicles like bicycles that can be motorized or not. But the idea is that the astronaut can have some exercise while they are working around. And there are many things that must be met technically, and we are working on that also. So, but then, as I said before, we need a lot of information about standards, operational standards, mainly. As I said, I mean, frequencies to be used, if they are there or not. I mean, are we going to have a positioning system? Will it be based on satellites around the moon, or will it be based, we can do it easier by using antennas in different parts or whatever? And that's the idea. I mean, we need to talk with other people so we can get some information, we can interchange ideas, etc.
Okay, thank you, Rodrigo. I know we are running late on time. John, if we can have another 2 minutes to ask Baha the last question, and then I will conclude. Thank you for the extra time. So Baha, the same question: what are the capabilities of Egypt, and how these capabilities can be linked to the Moon Village building blocks?
If we refer to the paper published on the human settlement in 2045 by the MVA Architecture Worker Group, which was published in the IEC last year, we may say that the Egyptian interest is solely focused on scenario beta, which is a scientific goal-driven lunar activities. Though the Egyptian Space Agency was recently established in 2019, there was an authority called NARS, which is an authority for remote sensing, which was established in 1991. And Egypt has a history of launching satellites before for scientific goals, which was the base for the establishment for the Egyptian Space Agency. And so if we refer to the building blocks concerning the MVA architectural work group, we would say it can include utilities like communications and network systems, navigation technology, imaging, operational sensing, computing and data management. Another block would be the in-space capabilities, like the cislunar space or the lower lunar orbit capabilities. Also, it would be interested in science missions and payloads, including specifically the space of the moon and the space from the moon, like astrophysics and geophysics for the moon itself. And last but not least would be the transport and logistics, exclusively in the cislunar space logistics. The Egyptian Space Agency is specifically interested in propulsion technology, communication technology in this arena, and the technology demonstration kind of missions. We may say that the Egyptian Space Agency is generally interested in two other blocks, the human operations and health, and the habitation and self-sustaining, like the biosphere. But that would be in a more journalistic way. There are current insinuation of interest in creating analogs in Egypt, using the desert capabilities in Egypt to exhibit such interest as actions. And so Egypt may appear as a young country regarding space technology, but they have a couple of ideas on how to progress utilizing their capabilities. Yeah.
Thank you, Baha. Of course, I wanted to have also an extended discussion about the relationship between emerging countries' roadmaps that we have and the Moon Village, but unfortunately the time has ended. In the end, I would like to conclude and mention that in the future we are planning to organize some webinars so that each country will have a dedicated 1 hour to discuss about the projects, the ongoing projects, and with a particular focus on partnerships, whether with institutional members in the Moon Village Association or individual members who are interested also to learn about different countries. So I would like to finally thank Baha and Rodrigo for their time participating with us. And also thank you, John and Madhu, for offering this opportunity. Thank you.
Thank you so much.
Thank you so much,
Ghanem. Thank you, Rodrigo. Sorry, I got confused myself.
Baha.
I'm Baha. Thank you, Baha, because I'm looking at the wrong damn piece of paper. I took my notes and then I shuffled them. It was a terrible mistake. Thank you. I think one of the specific activities which is underway within the ISIC-G which is a programmatic activity that didn't get mentioned, has to do with the involvement of non-traditional space agencies, such as the Australian Space Agency. However, the PESC program within MVA involves emerging space countries that have an interest and frankly are a part of humanity going to the moon, but may not currently have a space program. And so we are making a special effort to extend the participation in humanity and the moon to such countries. And the activity of the PESC and what Ghanem is organizing is quite critical to that. Ghanem did not represent it, but I'll just mention that at this kickoff meeting in Kuwait that I participated and which Oleg Ventusky participated in, there was an immense level of effort and interest among the young people in Kuwait. And I think if this is reflective, which I think it is, of the potential interest and engagement of younger people and people in fields that are non-traditional. You don't build rockets, but you know everything there is to know about agriculture or about mining or about that. This is a tremendous opportunity. So thank you to Ghanem and thank you to the panelists. We have a last minute addition to the agenda. Oleg, if you're able to wait for just a few minutes before we begin your remarks.
No problem, John.
Bintang, if you wouldn't mind introducing yourself and your topic.
Yeah, I share you the Zoom link, the link related slides, Mr. John.
Okay, very good. Can you share your screen or would you like me to download your file?
No. The file is in Google Slides. You can open directly in browser.
Okay, very good.
Can you see it? I just want to make a confirmation. Can you see it properly?
I see it. I see it.
Okay.
One moment. Please go ahead.
Yeah, Mr. John. Hello, good morning and good afternoon, ladies and gentlemen. Yeah, here I will present my presentation regarding the sustainable moon village technology based on MVA workshop on July 2021. Here our current team member for working on this subject. Yeah, here me as a team representative for this presentation. I'm Bintang, and other team members which is Sneha, Marcel, and Gagandit as a former for this, was a collaborator for this presentation, but they cannot present their writing portion, so I could handle all of the writing portion here in presentation session. Continue to the next slides, Mr. John. Yeah, here our present I will highlight you about the topics that I will cover. Next, resource identification, characterization, and so on. And then the first one is about the resource identification. Hello?
Are you there?
Okay. Yeah. I'm sorry for the trouble. It's a little bit trouble about this my sound. Here about the resource identification, characterization, and utilization. To have a sustained human presence on any extraterrestrial body, it's necessary to employ the lunar surface as a test bed for various technologies. Lunar I0 has been suggested for the self-sustaining habitation and future exploration of the space. And then after that, the first Apollo samples were returned. Various tests were undertaken to study about the volatile elements. And then all these studies suggested the evidence for magmatic volatiles, such, for instance, H element, carbon element, nitrogen, sulfur, and chlorine, Cl, in and around the moon. And then data from remote sensing can also be further used to understand in more detail about the distribution, origin, and abundance of volatiles on the lunar surface. Furthermore, new tools and technologies have been discussed for a few years now over the economic and sustainable method to produce oxygen and metal from the lunar regoliths. There are various methods available that can be explored. For instance, like chemical reduction, sulfuric acid treatment, electrolysis, and so on, for the production of oxygen from the lunar materials. Next slide, Mr. John. Yeah, here I continue to the next section about the process and system modeling of energy generation, storage, and transfer with in-situ resources. Harvesting, storing, and transferring energy through the use of in-situ resources on the lunar surface is one major area of interest in lunar habitat development. The energy can take many forms, such as solar, nuclear, electrical, and also thermal. The practice of generation of energy has to be sustainable and efficient to allow for the fundamental energy resource to be available. Then the energy is crucial for any activity on the lunar surface, be it science, habitat development, human and robotic exploration. Furthermore, using local resources on the lunar surface, such as lunar regolith, process of energy and power generation, including the storage, can also be developed more. For instance, some of the application can be seen from the slide. Yeah, the application consisted of 3 parts, such kind of fabrication of solar cells, and also the regenerative fuel cells based proton exchange membrane. Yeah, it's an example of regenerative fuel cell to store energy. And the last one is porous materials such as lunar fines and rocks used in further for energy transfer during the in-situ activities. Yeah, next slide, Mr. John. Yeah, about the process and system modeling of surface construction. Yeah, one of good case study is conceptual design of fast lunar landing pad. I take it from the Mason in-flight aluminum spray technique. Yeah, this project already developed by Hanabi Robotics in Texas and the University of Central Florida for upcoming Artemis mission. Yeah, I think for Artemis 1 for uncrewed flight that planned to be launched on March 2022. Here, the detail of goal and objective in developing the fast flight aluminum spray technique lunar landing pad is the underlying concept is implementing the engineering ceramic particles that injected to the rocket plume to form such a coating over lunar regolith as a lander descends on the lunar landing location. This will be done to prevent the impact of lunar dust, including razor-sharp regolith, in reaching out the lunar landers. this can effectively change the approach on auto landing on the lunar surface. Yeah, continue to the next slide, Mr. John. Yeah, it's also the continue of the previous explanation about the fast lunar landing pad. In my point of view, the engineering analysis for the fast lunar landing pad can be done into two ways. The first one based on numerical simulation, and the second one is based on experimental result. Yeah, for the numerical simulation, we can calculate the optimal landing pad thickness, the thickness of landing pad, and also including the material property based on the size and the temperature distribution, temperature and pressure distribution of the engine plume and pad spalling, using the data from flying Mason vertical takeoff and vertical landing of related rockets. And second one, we can potentially modeling how the particle absorb and reject the heat inside the engine and also during the travel, including the material adhesion to the regolith in order to optimize the impact velocity and material selection. And third one is the development of 3D printing, the reliable vision 3D printing landing pad based candidate material, and testing the 3D printing result with a hot fire rocket engine test which simulates a lunar landing and the effectiveness at mitigating the blown dust and also the deep cratering effects. Last but not least is conducting optimization based on all of the numerical simulation, all of numerical activity I mentioned previously, and also with the experimental result in order to meet a diverse set of missions. Perhaps in my point of view, we can also this lunar landing pad can also be conducted using the digital twins approach. And this is my subjective view. Yeah, digital twins can be implemented in order to further analysis and reliability to construct the fast lunar landing pad in the future activity. And also continue to next slide, Mr. John. Yeah, this is the last one. This is the last slide about the manufacturing and repair with in-situ resources. The main resource on the moon is regolith, lunar regolith, which is a combination of several basic chemical elements. Among these are silicon. Among these are silicium, Se, oxygen, and aluminium. The presence of this material on the moon has already been well proven and has several implications for manufacturing and transport infrastructure consideration. For one, it is possible to know which element really need to be brought in from Earth and which kind of parts could be manufactured on the moon. It seems prudent to not manufacture complex electronics in situ. It seems prudent to not manufacture complex electronics in situ, but limit production to one component, mechanical or structural part, at least at first. And also, it should be noted that depending on the target quality and the composition of the part of material, more or less sophisticated production techniques are required, and also perhaps the power demand might rise in the future activity. Yeah, that's all from my presentation.
Okay, thank you very much. I'm going to turn now to Oleg Ventowski, who's been kind enough to wait for a few minutes. So Oleg, if you would please take the floor.
Thank you so much, John. Hello, everyone. It's a pleasure to be with you. And John, thank you again for having invited me to share some considerations on the current state of the moon market. I'm sharing my screen immediately. So can you see it? Hello?
We can see you.
I see you, but I don't see
Oleg,
your screen. We
but not
don't
the
see your
screen.
screen.
It's strange because I have already shared it. Give me a second then.
Try one more time. Try one more time, Oleg.
What I can read, John, is that host disabled attendees.
No. I was recycling it because during the course of the last 2 days, occasionally that helped with someone being able to share. I recycled it. You now have permission. Please go ahead.
I'm trying again.
Thank you.
What about now?
Same.
Same.
Not yet.
Okay. Give me a second, please. I will try to remedy the situation. Something has no, it takes more time than I would have expected.
Are you trying to share it at full screen? Sometimes if you just shared a view of the slides, either in PowerPoint or PDF, then it's okay without going to full screen or slideshow.
Okay, John, maybe you're right. I'm trying to do my best. The point is that when I come to sharing screen, I don't see my screen, in fact. I don't know why. John, may I suggest that maybe in order to not to lose time, you move forward and I try to fix the problem meantime.
Okay, that would be fine. How large is your file?
I think I need a couple of minutes.
Well, I was just going to ask if you could email it to me.
Okay, I will do this immediately. Thank you.
By the way, it seems like every time we have a meeting of one kind or another, that there's always something very exciting related to the moon happening at the same time or close to the same time. In the last few days, there's been quite a bit of discussion in lunar science circles about the upcoming impact of a Falcon 9 upper stage on the moon. And right now there's a fair amount of crosstalk. It's going to impact on the far side of the moon. And there's a lot of discussion about how LRO might be, Lunar Reconnaissance Orbiter, might be positioned to image the impact event, sort of analogous to the L-Cross experiment of some years ago that provided some ground truth on the chemical composition of the lunar regolith at the pole or near the pole. And so I think this is going to be another really interesting data set, but it'll probably take some time to get it published through the peer review process. Perhaps we can hope for some quick online sharing of data or results. I'm just now reading literally as we're meeting that LRO's altitude at the impact point is predicted over the impact point is predicted to be about 100 kilometers, which would really be terrific because that would be a 1 meter per pixel resolution. So very, very, very exciting, very, very dynamic opportunities for data concerning the lunar regolith composition. Oleg, were you able to send it successfully?
The problem, John, that I need to use a V-transfer. So it's in the process now because the file is big.
Okay, very good. So of course, because of the need to schedule this event across multiple continents and time zones, many of our participants are not with us at this moment, unfortunately, but will be joining us later. For the sake of the conversation, and while we're waiting for Oleg to
You received it.
You're muted, John.
I wasn't speaking anyway, but nevertheless, give me just a moment. I have received it. There we go. There we go. I'm downloading it. I'm assuming that you're a safe risk, Oleg.
Yes, indeed.
I hope so. We are 50% downloaded. It's a big file.
Yeah, indeed. And my sincere apologies to everyone for this delay.
Oh no,
I don't know what happened.
This delay is approximately equivalent to me getting my cup of Earl Grey a few minutes ago. So no worries.
Okay. You reassure me, John. Thank you.
Okay.
Meanwhile, John, if I can you see now?
Now we can see it. So, so it just needed some time to rest.
Let me start. So my name is Oleg Venskovsky. Without further ado, I'm with Yuzhny Design Office as director of the European representation in Brussels. And I'm also with Moon Village Association, a member of the board of directors in charge of the Moon Market Development Coordination. Here is what I was going to discuss with you briefly. First, contours of the Moon market. How big, in fact, is the Moon's commercial potential? how one can quantify it, MVA's unique role and contribution, and importantly, how one can get involved, and time permitting, I'm ready to take your questions. So first, contours of the moon market. We all know that there are some very important movements with regard to the moon market, in particular what concerns CLIPS program, in a moment on this, telecom and navigation services, space transportation means, in-situ production technologies, scientific instrumentations, etc., etc. The list is endless. And it's also evidence that we should speak not only about the moon itself, but when it comes to the moon market or moon-related market, we should take into consideration cislunar space, LEO, and I would even say the Earth itself, because, for example, we did not have today the presentation on the subject, but if we refer to the analogs of the moon surface, there is already a competition, and fierce competition here on the Earth with regard to this aspect. So all in all, we should speak about the nascent moon market of goods and services as a new segment of the global space market. Now, you would agree probably that CLIPS program is something that gave a big boost to the developments, in particular in what concerns lunar landers and the means to deliver payloads to the lunar surface. In this particular case, NASA pays to potential vendors, and there are currently 14 such companies, mostly startups, for the NASA payloads delivery to the lunar surface. We eagerly waiting on the Astrobotics Peregrine lunar lander first launch later this year, followed hopefully by some others, in particular by iSpace from Japan. Elsewhere in Europe, we have a very interesting initiative called Moonlight. It's about bringing a connectivity to the moon. This way, ESA fosters creation of a commercially viable constellation of lunar satellite. The basic point is that the shared telecommunications and navigation service would make each individual mission more cost efficient. It looks evident that if I plan something to launch over there to the moon, why should I bother investing time and financial resources for the communication and navigation if there is a service already in place which could be easily or relatively easily taken? So this is a basic assumption and very right one. And with this, ESA pays contracts to two consortia led by SSTL from Great Britain and Telespazio from Italy. The target is to have 3 to 4 satellites in the lunar orbit and to secure up to 30 meters accuracy. The constellation will be to the agency itself and to the other customers. The ESA expects that this initiative will be a catalyst to inspire more exploration missions, and I think rightly so. The Moonlight was launched last year, and just a couple of weeks ago, there was a kind of a follow-up. There was an announcement of Lunar Communications and Navigation Services call for ideas and attention, use cases. I think, John, that the agency was inspired by your reintroduction of the notion of the use cases, probably. We can see on the right-hand side of this slide that there are different areas where this call for ideas and use cases are expected to be found, starting with demonstrating the feasibility of ISRO in support of human missions, logistics, artificial intelligence, etc., etc. Each idea should aim at supporting short-term and/or long-term human and robotic exploration of the moon and the development of the lunar economy. ASI, the Italian space agency, also contributes to the Artemis program by, in particular, investing some money into the 16 key high-level architectural elements to be studied within the project by Thales Alenia Space. And among the elements are rovers, orbital platforms, surface habitats, and also a lunar data center. This center will form a part of the LunarNet NASA project, and it could be built, as they claim, on the moon before the end of the decade, of this decade. So the idea is that this lunar center, lunar data center, can help to sustain heavy computational demand. New types of missions and applications will become possible with this. You see, it's another movement in the same direction to create already a service which then will be used by all the entities and companies which are interested in the subject. JAXA in Japan cooperates with non-space actors, in particular with the company called Kajima. I took this example just without special intention, because JAXA cooperates with some other non-space actors, and we know very well what are they, in particular Toyota, Honda, and other players. But in this particular case, we have a construction company which has an agreement with JAXA since 2016. And last year, experts from the two entities were able to maneuver a stream roller from 1,000 kilometers away. They had to anticipate where the stream roller would be several seconds later, because, as we all know, images would take time to arrive from the moon. Now they want to try it at a longer distance. Back to Europe, the French space agency CNES and l'Association nationale de la recherche et de la technologie, National Association for Research and Technology, also last year joined forces to boost a lunar economy. There are some very ambitious goals declared, like a lead cross-sectoral thinking by public and private stakeholders on the lunar economy, spark disruptive innovation for a lunar economy, foster cross-sectoral convergence, and I ask you to remember this, to boost entrepreneurship for the lunar economy. This is something we will come back in a couple of minutes to, and already mentioned by me as space exploration analogs. So, how big is the moon's commercial potential? There were several studies already done on the subject. I would refer in particular to the Colorado School of Mines in 2018. The team asked if and how private business can harvest and process lunar ice as the foundation of a lunar, cislunar, and Earth-orbiting economy. Under the key assumptions that everything will be done by robotic systems, that is construction, operation, transport, maintenance, and repair, they come to the conclusion that technical and economic feasibility of establishing a commercial lunar propellant production capability are there. So what concerns the concrete estimations, the study concluded that a near-term annual demand of 450 metric tons of lunar-derived propellant, equating to 2,400 metric tons of processed lunar water, generate $2.4 billion of revenue annually. Luxembourg Space Agency the same year issued a study called Opportunities for Space Resources Utilization, Future Markets and Value Chains. The value chain for rocket propellant offers the most viable business case and best near-term opportunity, they concluded. The transportation of humans to different celestial objects will drive a major part of the demand for fuel. In space servicing industry will also be a primary user of fuel such as methane and water. What concerns the mid-term business opportunity, they were identified life support, space infrastructure development, and in-situ equipment manufacturing as the most perspective directions. These areas will drive the demand for metals, in particular iron and nickel, and regolith. In the longer term, they singled out the platinum group metals value chain, primarily due to technical challenges to extract the elements from in-space locations. There was an interesting, visibly study published in April, if I'm not wrong, April 2021, by the think tank called Northern Sky Research, probably well known to you. It was the first attempt, as far as I know, to cover all the, or almost all the markets related to the moon. Unfortunately, due to the fact that the study was only available commercially and the cost is quite high, until today, I don't know what is inside. If someone had an opportunity to look into the report, I would be glad if you can share with me and with others what is the contact. But we at MVA are doing something at least not less interesting, but I believe much more interesting and precise. And this is the part of my presentation to which I'm coming now. There is no big reason to go into the description of the MVA's unique role. I would like just to return to the last para of this slide, which says that MVA cooperates with interested stakeholders in both spacefaring and non-spacefaring nations. And our previous panel is a good testimony to this, and it's really a very, very important direction of our activity at MVA. This is a panorama of all the institutional members as of today, 33 and counting, who we call moon market pioneers. They are, among others, interested to address the following issues, the following questions to potentially expand their portfolios. What are available market niches? Are the technologies they possess applicable to the moon? If so, what kind of adaptation is required in terms of time and necessary investment? What competition will be faced when they come to the moon market? What is expected timeline for the moon-related businesses, etc., etc. And definitely the activities MVA is undertaking nowadays are very helpful to address this and other issues and questions. And you are already familiar with the MV Moon Village Architecture case studies building blocks introduced by John Mankins and his team. And we also know about the use cases thanks to John's paper presented at the last International Astronautical Congress in Dubai, and excellent presentations the first day, the keynote. But at the same time, extremely interesting and important work is being done under the guidance of Derek Weber and Gidon Gotel within the framework of what is called Lunar Commerce and Economics Working Group, created 1 year ago, which provides a forum for promoting an international and interdisciplinary discussion of all potential markets for goods and services that will form an essential part of the Moon Village operations. It provides a focus for businesses who are considering supporting lunar activities and for government planners who seek to understand the time frame of and degree to which commercial business will be able to contribute to the endeavor of developing the Moon. So let me briefly tell you what is the situation today with the working group progress. From the very outset, I should say we had a very impressive interest from the community, more than 200 applications, out of which 85 group members were selected, 9 subgroups created corresponding to 9 market sectors that were identified. And the major outcome which is expected hopefully by the end of this year, maybe even before, it's the so-called Lunar Commerce Portfolio, which is, allow me to say, a living Bible for the entrepreneurs dreaming to have a business on the moon. Why living? Because this is not going to be a document final once and for all for all the times for the future. It will be updated on a regular basis by the team members, current and hopefully future. And to create it, huge work has been already done. I simply do not want to go into details because Derek Weber knows much better all the nuances of the work which is underway. But what is important to mention is that last year in June, the working group organized a seminar where the basic methodology was presented, among other things. In particular, that the work is based on the demand approach. They were explained value chains. By the way, if you were present the first day, you might have noticed Derek's remark, a brief remark, that there is a similarity between the value chains which are being considered within the framework of the working group and the use cases introduced by John, which is very interesting, and there is certainly a field for synergy here. And also the horizon is that the group considering early and mature time phases. So time horizon is like this. As of today, qualitative assessments are almost done, and the quantitative stage is about to start. Importantly also, please pay attention to this. I know that Dallas and Christoph are important members of the group, but new team members are still welcome, of course, subject to the selection procedure. But if any one of you feeling that you can contribute to the developments, you are most welcome. I will be brief now to wrap up on time. The MVA also pays a great attention to the engagement of the non-space businesses. We have created a special series of events started in 2020 with this workshop, which is screenshot from which is just in front of you. You can see that we had the head of the space agency at the time. It was co-organized with ESA. We had representatives of Asia, Japan, Thailand, and Europe. We have come to very useful conclusions, in particular that we should continue with some dedicated events. And the next dedicated event happened just 1 year ago after. It was in September last year. Again, we had a very impressive set of participants. You can recognize some faces. And we concluded that some important developments are going on in different companies across different areas of activities, non-space and space. We put a special emphasis on R&D as a necessary means to nurture the economic perspective. And we believe that the results of the workshops already done will serve an interesting and important inputs for both MVA Architecture Working Group and Lunar Commerce and Economics Working Group. Tentatively, next workshop will be dedicated to automobile industry. And the last thing I would like to draw your attention to, the Moon Village Association, together with Yuzhny Design Office, my native company, would like to contribute to the entrepreneurship development vis-a-vis the Moon. And we have launched this initiative called Promo Moon for in the memory of Dr. Alexander Degtyaryov, a big promoter of the moon-related activities, who spent all his career at Yuzhny. The details of the initiative, which is calling to calls for ideas, solution concepts, and projects for lunar-related technologies. The details are available on the website. Again, there is a possibility to be engaged in this initiative. And if you feel that you can serve as a coach, as a mentor to the applicants, please let me know, me or my colleagues at Yuzhny and MVA, and we gladly will use your services. Thank you very much. I'm done with this. John?
Thank you, Oleg. That was terrific. If you wouldn't mind now, after all the trouble we went to get you to be able to screen share, if you wouldn't mind stopping screen sharing. Thank you so much. I know we're running a little bit late. We're not going to run for the full end of the session as it was planned. I know it's very late where many people are. Does anyone have any particular questions for Oleg?
I have one, John.
Please, Madhu.
Oleg, I have always enjoyed your presentation and your style, and your rate of delivery is also very interesting. Thank you very much. Now, one of the things that I brought up, and I think I mentioned this to John as well, is extending the case study to also one in which we are looking at clean activities on the moon that can reflect on how we should go about doing things on planet Earth. Now, I've not framed a topic title for this, but I wonder if you appreciate that angle of how we intend to conduct activities on the lunar surface or in orbit or in cislunar space that can benefit all of planet Earth by just looking at what we do on the moon and saying, why can't we be a cleaner species on Earth? Thank you. And I see Bernard has just joined us.
Get to that in a minute.
Thank you very much for your kind words. I appreciate, Madhu. This angle is extremely important, no doubts. Frankly, we do not pay enough attention, I think, at this very moment to this particular important aspect, but it is not completely out of our radar, I should say. So, yes, we should take this into consideration and to explore and utilize the moon responsibly, in a responsible way. I think it's subject of the UN COPOS working group on the sustainable lunar activities, to which MVA contributes heavily nowadays, with GEXLA in particular. And within the frame of these activities, we will certainly address this aspect as well.
The terms we use, particularly in the architecture school, I hear this more often, is ecological footprint, minimizing the ecological footprint and being conscious and sensitive to the environment. And we do that in space activities now when you look at how we fly missions. And maybe there is a proactive way to suggest that what we will do on the moon will set an example for things we do on Earth.
I believe you're right. Yeah.
Thank you, Oleg. It's such a nice presentation.
Thank you.
Hello,
So
this is Richard Fisher. I had a question if I can.
I'd like to, Richard, I'd like to respond to Madhu for just a second.
Okay,
so
yes, sir.
please pause for a moment. Madhu, another way this is described internationally is the term sustainable space activities or a sustainable moon. And there's actually quite a body of literature from the UN on this subject having to do with the space, or it has come from the ISU, the lunar version of the sustainability goals from the UN. And so I might encourage sort of a common reference from Oleg and Derek in that direction, and from you from your next design studio efforts next fall at USC, how to do a sustainable moon. Now, Richard, I please go ahead and ask your question, but I want to mention that Bernard Fong has been able to join us now. He was tied up giving an exam in a class, and I'd like to, since he is here, I'd like very much to give him the opportunity to give us his presentation. Maybe only a 15-minute version, if that was possible, Bernard.
Excellent. Yeah, thank you so much.
But since he's here and he's able to join us, I don't want to miss the opportunity. Let me ask Richard, if you'd go ahead and ask your question to Oleg, and then we'll move to Bernard rather promptly after.
Okay, well, I'll just make it real quick and short. I quite frequently have the opportunity to talk with different industry stakeholders, and one of the critical things in terms of trying to get their interest in the moon is, well, Richard, all you have to do is show them how to make money, on it. And I really enjoyed this presentation, and certainly would like to provide an opportunity for the Moon Village Association to share that with these particular stakeholders in the future, if we could do that. So I'll just leave it with that statement and let you guys continue on. So thank you.
Okay, Richard, thank you very much.
Yeah, I think there's a legitimate argument to be made that Huntsville is one of the Silicon Valleys for space, and if that's not offensive to people in Alabama, but I think I couldn't agree with Richard more about the opportunity. If I could now turn the floor over to Bernard. Bernard, we're so glad you were able to join us. Please, you have the screen share.
Thank you very much for your patience, and it's a great pleasure to be with my Moon Village Association of friends. As you know, I was promoting Moon Village since with Ludwig 25 years ago, but now you have made it really happen to the base. You have involved a large part of the community, grassroots from all countries. And I would like to share with you some work we have done on the area of lunar analogs, where also we try to involve hands-on the community, in particular the community of young professionals. And for this, okay, I want to apologize as well. We are in the middle of the final master presentation review of my students from École Polytechnique Fédérale Lausanne, EPFL Lausanne. So I have 30 students that each had to present a 15-minute talk designing a spacecraft to the Earth or solar system. And so there, I was very tough on time for them, 15 minutes. So I will try to do the same with you now, 15 minutes, which has given to me by the chair. So I would like to report on our activities on the Euromoon Mars. We have expanded it to call it Earth Space Innovation because we develop also many activities on Earth observation, also Earth campaign, and also some activities on innovation, entrepreneurship, and funding. And that's a program we started some 12 years ago, funded at the beginning from ESA, NASA, also with the International Lunar Exploration Working Group. We have also created a foundation for that to manage some of the funding flow where we give grants to researchers, young professionals that are participating to these activities. So some activities are to analyze data, to prepare instruments, to test them in the field, and also to do some astronautics training. And we have added new activities where we design habitats and we develop business case, and even we have integrated art. So a new platform, Art Moon Mars, and another one called Moon Mars Foundation, where we raise funding for all this project. So every year we have a number of young professionals joining us. So I've put some of the name of the group that are involved here. But just for you all to know, I retired from ESA last year exactly. And so this time I have some opportunity to develop this work, also including some academy and network of institutes, universities, and also entrepreneurs and companies that are fostering our goals. So, okay, Moon Village, our midterm goal is some sustainable presence on the moon, but supported by a large Moon Village community on Earth for benefit to Earth. And one element is to analyze data from previous missions. So this is the data from my baby Smart One, where we analyze processes on the moon that tell us about the Earth and rocky planets. So we have also explored some region where we want to go next on the South Pole. This was the images we obtained with the Smart One probe of the permanent shadow areas where we found ice later, and also some eternal peak of light. Now we are in the phase of the robotic village that has started in 2013, permanent presence with robot, with the Chang'e 3 mission and its rover, U2. And now we have got also other landers, Chang'e 4 on the far side, Chang'e 5 with sample return. And now this year we will have a number of robotic missions from various countries, also some commercial actors. So if you remember, some 27 years, we gave a roadmap towards the Moon Village. So with precursor orbiters, robotic village, human outpost, and then permanent sustainable human base. And so now we have tried to do some hands-on activities with collaboration between universities, but also agencies and companies and entrepreneurs to test some of these elements to prepare not only the hardware, but also the people to engage them. So we, some 12 years ago, we built Google Lunar X Prize, a small lander demo version to test how you can put some rovers on it and test some protocol of cooperative robotics. That will be the next step. And this we do as also a program where we train engineering students and scientists to do that. Eventually, I even work with the French Air Force cadets. These are very good astronauts because they are disciplined and they are very good physically. And so they test some of these instruments and hardware in extreme conditions. Here, it's a campaign that we conducted also where we had access to an astronaut suit from the Austrian Space Forum. And we tested this human robotic partnership. And we are continuing on this line because this will be something which will be very beneficial for our next phase of exploration. And so we have to develop the technology, the operation, and the human protocol for this partnership. So we have been also working since 2017 with the top planetary robotic institute in Europe. So that's the German Aerospace Center, Mechatronics Institute, in collaboration with the European Space Agency. And for that, we conducted a robotic alliance exploration campaign that took place at Etna. This looks like the moon, but it's in fact the Etna, where we deployed two intelligent rovers, teleoperated, but also very autonomous, that could deploy some payload out of a big lander. So we were planning to do a campaign 2 years ago again, a large scale with 50 people from DLR, 20 from ESA. Because of COVID, it was postponed to this year, June 2022. But with my Euromoon Mars Earth Space Innovation team, we had a kind of intermediate scouting campaign we conducted this year in July, in a very controlled pandemic conditions. And so eventually, I went there, actually with some students that just started with me this year, that I'd never seen personally because of COVID. They did their master research remotely. Some of them came to Leiden. So I have a group from Dublin that did some work on drone, on rovers, on panoramic cameras, similar to the ExoMars one, with a spectrometer, or with a radio antenna, similar to what we will want to deploy on the far side of the moon. So this was a group from Dublin, and then I had a group of 6 students coming from all parts of Europe that started their research virtually first, but then eventually we had some of them visiting, testing some of our rovers, landers system in the Netherlands. You know, we have also some granular terrain on the. This is our rovers. We have also a field area close to ESTEC where we can test cooperative robotics. But eventually, we all met in Etna. And so here we met on Mars in a mud pool that is on the base of Etna, very similar to Mars. But also we went and conducted some simulation of landing a small shoebox spacecraft on the surface of the moon, deploying some rover, deploying some cameras, exploring with a rover, picking some samples, analyzing them, and then retrieving them in the laboratory. And so, yeah, sorry, yes. Also, I mentioned we went to Mars as well. There are some areas very similar to Mars. We deployed some radio telescopes, some optical telescopes to study also from there some astronomy, and as well the Sun and Jupiter that we'll be able to also measure from the radio telescope on the moon. Eventually, we were surprised by a volcano, Etna, and then we had also the opportunity to visit a volcano in action. So this is the Etna volcano with a plume of 400 meters height, and we got closer, 4 kilometers, to see this amazing scene. And this is to illustrate that we can explore analog of the moon or Mars on Earth, but even on the volcanic episode that took place 4 billion years ago on the moon. So these are the number of the sites that we use for our experiments. So Etna, Hawaii, where with Anchorage and International Moon-Based Alliance, we are running the ICES habitat now, and a lot for short-term lunar-like expedition, like 2 weeks or 4 weeks. And we have used before Utah Desert or Atacama Desert. We are going there in February, or Iceland. So I mentioned about this work on cooperative robotics with a young professional where we tested, but also we locked down some of our team for 2 weeks like they would be on Mars or the moon, to test some laboratory and field research, to demonstrate some instrument, also to look how to optimize the habitat technologies, also from the interior design and operation, and looking at all this human aspect of performing in isolation. And it's a great platform also for training young people and advanced people together, and for outreach. So an example of the science we conduct, we are in collaboration with NASA Ames. We deployed X-ray instruments similar to the one which is on Curiosity to analyze rocks. We have Raman, like the one on ExoMars. And also we perform extravehicular activities outside. This was with a JPL radar, ground penetrating radar, or drilling with NASA Ames of deploying a rover. So since 10 years, we developed this platform, Euromoon Mars, to train young professionals and to perform research. And every year we organize 2 Your Moon Mars workshops where we mix up all these young professionals and the seniors one, so including astronaut candidates, robotics, even astronomers, engineers, and so on. And more recently, so we have access to the IC's base from the International Moon Space Alliance, where we conduct some research campaign there. So we call them EMIS, Your Moon Mars, IMA IC. So these are, for instance, geology researcher going in the field to explore lava tube and to pick up samples. They document them because they are doing their master research on it, so they had better to apply a good protocol. We have also a program with the Analog Astronaut Training Center in Poland, where we locked down some lunar astronauts for 1 week in a base without window, and we see how they work in a confinement. But we also deploy some other training, like building rockets, low pressure simulation, skydiving, a parabolic flight, and so on. So we perform such simulation, like for instance, this was before starting a 2 weeks isolation. You see all smile, also doing, and they were fed with plant grown in situ there. So we, even in terms of pandemics, we were able to organize sessions there, but with a very strict protocol. So you see with the workshop that was conducted there. Eventually, last year, we also celebrated Gagarin 60 years with a great public outreach event with all our Your Moon Mars astronauts and the public. And we also conducted a series of campaigns in Iceland, in particular inside lava tubes, to simulate how to deploy an habitat there. And we had this campaign this year organized actually by the young professionals themselves, where they designed an emergency shelter that they deployed in Iceland. So as a summary, this is how from the technical side, scientific side, we helped to prepare some of the implementation of a base, but there are also a lot of human aspects and cooperation with robots. We are doing some research also in making resource utilization demo. But the new things, and that's very much at the core of the Moon Village, is how you involve the users and a large part of the community from the non-space, from the terrestrial community into it. And so that's how we try to prepare for our contribution to the Moon Village, in particular with instruments, with new methodologies, and with training, and as well with experiences. So eventually, sometime we land with our lunar lander in the middle of the city, also to do some outreach. And we have started as well an academy where we provide certification for all this training, theoretical, experimental, astronautics, and also business training. So we call that EMATA. And eventually, we also work a lot with the International Astronautical Federation, with various committees. Here is our committee on the cultural utilization of space, where you see people from all countries and also from all generations. So that's my report about Your Moon Mars Earth Space Innovation to the Moon Village. Thank you very much for your attention.
Bernard, thank you so much, and especially thank you so much for your speed and your energy and your information coming out of a saturation with the students.
Yeah, but the students were amazing. They will all present at ISC, hopefully. Very original concept of a space mission. So I think that it was a great day to see how much you can be also energized by the young professionals when they are given a challenging task.
Fabulous, fabulous. Do we have any quick question for Bernard? Maybe just one?
Only a good thank you for the presentation.
Okay. Very good.
Yeah.
So,
and of course, yes, if you're interested to join us, we try to provide opportunities, and we organize some workshops. We organize also some session at ISC, and so we are also looking at working with some of the working group of the Moon Village Association that have approached us on the analog side, on the habitat, and also on the cultural utilization of the moon.
Wonderful.
And John, maybe you mentioned that ISU. I think ISU can be a glue in many of the activities, particularly with the PESC group. We know people from ISU in Egypt and in Chile, and hopefully we can connect them all together, John.
Yeah, absolutely. So it's
Actually,
something
this
that we
week
can
I
work
am
toward.
at ISU. I am exactly now this week at ISU.
That's right.
So,
You're all the
we have
ISU gang.
a collaboration on the space habitat. Yeah.
So forgive me, I want to go ahead. We're already way past time. I'd like to get us to the point of closing this workshop and putting a ribbon on it. I just want to remind everybody where we've been. So this has been a 3-day event. We started out on Tuesday with an opening presentation on the MVA architecture case study, presentations from NASA, from CAST, from ESA, STEC on their lunar activities, from several universities in Japan, and also a presentation on research that was ended up giving Michael Blanc, but from a lady from CAST on
Linguo.
Lin Li.
Linguo. Yeah.
Yep, Lin Li Go on thank you. On on Wednesday, day 2, we continued our discussions, delving into some more technical meat regarding space transportation and infrastructure, some trade studies that were done, overview of Teles Alenia industry activities from Maria Antonietta Pereno, and then continuing with discussions of a key topics including energy and comms for the moon and science on the moon. And today, concluding with discussions of some architectural concepts and activities from the USC studio that Madhu runs. And I should have mentioned that, of course, on day 2, we had an excellent overview of the evolution team activities from Professor Inetani, who I believe at this point has gone to bed since it's very late in Tokyo, and a very nice presentation from Dr. John Rummel on bioregenerative life support system. And in the minutes, we're going to put Bernard in just where he is in this schedule in the report from the workshop. And we had an excellent working discussion and presentation from Naoki Sato, who was representing the International Space Exploration Coordination Group, and then discussions from the PESC program, Ghanem Al-Taibi, and two PESC panelists representing Egypt and Chile, and then a discussion from Oleg Ventowski, as we had planned. I'd like to just highlight briefly a few items that will, I think, be important to recognize. One, things that came out of the discussions, and there are going to be many other highlights from the discussions the last 3 days. From the conversations, it's very clear that there is a need for coordination that the MVA can provide on issues related to interoperability and standards for the longer term future of the moon. The formal government programs as represented in the ISIG are very much focused on the nearer term, and the international efforts there are focused on the moon pretty much only as a stepping stone to Mars, and not looking at the longer term future of the moon, which is something which is of great interest to many and is already being pursued by various programs and organizations. There are a lot of different visions and opportunities for key functions and technologies. We're going to have to find a way to reflect those as variants on the building blocks that are, and the case studies, the use cases that are in the architecture reference case study. It's clear that there's tremendous interest and activity concerning lunar construction and in-situ manufacturing, the use of the regolith. However, these specifically are not in the International Space Agency planning through the ISIC-G. So this is a topic of, it's being undertaken by various technology programs at NASA, JAXA, and universities and so on, but it's not a subject of emphasis because it doesn't relate directly to the moon as a stepping stone to Mars, which was sort of the foundational assumption of the global exploration roadmap. I wanted to mention that next fall, the Moon Village Association workshop and symposium will be held in conjunction. It would be a face-to-face event, but it'll be a hybrid event. It's going to be held in conjunction with the National Space Society Space Settlement Summit, the second week in November. So November of 2022, we are hoping to return to face-to-face meetings, but with the hybrid flair, which is so important these days as we work through the next several years. These will continue to be critical. We certainly would like to invite and welcome inputs and thoughts from all of the workshop participants, those who are here now and those who are not here at the moment. So please do share with your friends and colleagues our interest in inputs and suggestions. It's clear that we need to both broaden and deepen the defined use cases that I presented to the community for this workshop on the day 1 and day 2. For example, including comms, following on the trail breadcrumbs laid by ESA's Moonlight initiative, and also work being done by the scans office at NASA and JPL with regard to networks and communications for the moon. There's a need for better coordination between the markets and economics working group of the MVA and the architecture working group, and Derek Weber and I talked about that offline yesterday, and we're going to be pursuing that and other areas. The goals are largely unchanged for the current architecture working group activities. We're going to continue in 2022 the case study that we've been looking at. We're going to do more modeling based on a broader and a more refined set of use cases, and we'll be trying to look more at the issue of sustainability and how lunar activities can be, especially for the longer term, can be shaped to assure that they are sustainable and both benefit terrestrial efforts in sustainability and reflect a broad international interest in lunar activities, especially longer term, more ambitious activities like the development of lunar resources, to assure that those activities are in line with the goals of sustainability that have been identified by so many. Madhu, any other closing thoughts or observations on your part?
I thought that it was a very good architecture meeting, John, and I was happy to see the different countries and different participants from agencies and academia. Thank you, Bernard, for joining us in the last minute. And I really got a lot of information. We all keep our radar out, but it's always a pleasure to hear other groups talk about their thoughts. A thought that comes to mind, John, is that when we involve different participants from different, I like to call them cultures more than countries, because some of these cultures are very deep compared to what we do here in the United States, the way we approach this whole issue. And I find that fascinating that we are able to engage China. We missed, did we miss India this time a bit? Perhaps we did. And I would be representing India as a fake Indian, but I'm happy to do that. And I was also happy to see.
I would have been happy to invite anyone you suggested, Madhu.
I know, but we wanted a few people, but I guess, and also this time around, did we make the workshop happen very quickly as opposed to the first time we tried, John?
Well, actually, the time was about the same, both instances.
Same.
The big issue for us this time was because of a conflict with an ESA meeting, we weren't able to do it in close proximity with the main MVA workshop, and we ended up having to do it after the holidays. And I have to say, you find out who's in a different culture when it turns out they're not coming back from Christmas until January 17th.
Okay.
So there were quite a few instances where a lot of the folks who ended up participating actually were not available to circle up until just a week or two ago. I'm hopeful that by holding the event in November this coming fall, that'll ameliorate some of those issues.
I'm sure.
Do you have the day in November when you plan it?
Yeah, if all goes well, the event will be, I think, on November. Let me go forward to the dates. November 8, 9, 10.
8, 10. And the place for those
will be in Los Angeles. If all goes well, again, the contracts aren't signed yet, but if all goes well, it'll be located quite close to the LAX, so that it'll be really convenient for travelers to come in, go to the workshop, and minimize their expenses.
Excellent.
Good. On the 8th of November, don't miss, there is a total lunar eclipse.
Oh, wonderful. Well, we can all go out
And
by
we
the
were
pool.
planning to organize an event in Hawaii around that time.
I'm sorry, I'm not going to Hawaii. I'm going to be at the MVA.
No, but this is visible. This is only visible from the Pacific Rim.
Oh, that'll be perfect. That'll be perfect.
Yeah.
Very good. They're very good. We will definitely exploit it. We'll arrange a moonlight or a moon eclipse event at the pool outside the hotel. I like it.
Yeah. Then you go from full moon to red moon. Yeah.
Lovely.
So, John, I think in conclusion, I thoroughly enjoyed the way you ran the meeting. We applaud all the people who spoke. As I mentioned, we got a lot of information in this workshop. When will you post this for all to see, John?
A very good question, Madhu. I couldn't hear you clearly, though, so maybe
let's say that again.
We'll have to
I hope
talk
Giuseppe
about that
hears it.
offline. Anyway, I will just say there will be an actual report. It's going to take a little while to pull it together. The videos from all 3 days will be posted on the MVA website and will be available to look at. And we're hoping to make available either versions of the slides that were presented or extracts from those slides. It was frankly a stupendous volume of material, comprising something like 2 gigabytes of slides and 2 gigabytes of videos.
Good. I think that's great. And John, I think everybody will appreciate this. And some of the terms we use, particularly the one that we all mentioned in the last few speakers, which is sustainability, and is the mantra also of the United Nations sustainability goals. And I think we should make inroads into that arena, John, to say that, you know, all of us are trained to look outwards, and it reflects in many of our thoughts and visions. It is also a good time to think looking back from the moon towards Earth. And I say this because a lot of stuff is happening here at NASA about exactly this, because our new administrator is an advocate of climate change and earth sciences. And obviously it's come up the rung. And so we will do what we can to bring that also into the picture in a full light. Can't thank you enough, John, for doing this. You do all the heavy lifting, and you keep up that smile, and your composure is amazing. And to do this at 5 a.m. in the morning, you know, this is when when a lot of people here are still slowly getting to speed. That's true for me too. But thank you very much again to all of you to have made this a very good workshop.
Thank you,
John.
Madhu. Is Inatani Sensei, are you still with us?
I sure hope so.
Yes, I am.
Oh,
great. I'm so grateful. Thank you for staying with us.
Yeah. And yes, thank you, John and Madhu. And on this occasion, this workshop on this occasion, it was very, how do I say, good, and many discussions and diverse topics are incorporated. That's a very good symposium. Thank you very much.
Thank you,
Inatani Sensei, and thank you for the extremely strong participation from Japan in this event. It was really noteworthy.
Yeah. Yes, it's of my pleasure to hear that.
Oh, it's just true. It's just true. So desu ne. Any other closing comments from anyone? I know Giuseppe Ribaldi, president of the MVA, is I think still with us. Giuseppe, would you care to say a closing remark before we say goodbye?
John, well, first of all, I'd like to thank you, all of you. I think you did a great job. I already indicated in the chat. No, I think you said it all, and I think it's time for the people to leave, including yourself. So I think I'd like to thank everyone. It was very interesting. I think you have highlighted an important role that now MVA is going to take in a number of areas, having clarified the possible overlap. So I think we have a good plan. The last remark that maybe has been missed is that we have an International Moon Day, ladies and gentlemen, which has been approved thanks to our suggestion from the Moon Village Association. Is the 20th of July. So please take into account in your own planning to use 20th of July as a major place for having event in your community or whether you know your network. It's very important. It's the first time, and this is going to be a huge success for everyone, not only for us. So with that, thank you to all of you for this great job. Thank you.
Okay.
Thank you, Giuseppe.
Okay. Thank you so much to everyone. I apologize if I didn't get back to everyone who might have wanted to say a few words, but we're way over time and we really should adjourn. So thank you to everyone, and look forward to seeing you at the IAC in Paris and in person, I hope, at the next Moon Village workshop and symposium in Los Angeles.
John, I want to say thank you like this.
Yeah.
Yeah,
okay.
exactly.
Merci.
Exactly.
Thank you all.
Merci, John.
De rien. Good night.
Good night.
Okay.
Thank you. Good. Bye-bye.